Okay, so let's remember on how we multiply numbers. So for this lesson, we'll be multiplying numbers. First one, multiplying by 2. Let's see. 1 times 2, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32, 64, 128, 256, etc. Agreed? So all after multiplying by 2. Each one, right? So be careful. Up next, number 2, multiplying by 3. So 3 times 1, 3 times 3, 9 times 3, 27 times 3, 81, 243, 729, and 2187, etc. So you can keep going until you get tired at least, right? If you choose to. Number 3, multiplying by half, starting from 16. Notice we have a specific starting point for this one. For the previous, we kind of chose one randomly. So 16, half of 16, or 1/2 times 16, 8, right? 1/2 times 8, or half of 8, 4. Half of 4, 2. Half of 2, 1. Half of 1, 1/2. Half of a half, well, think about it like going half of that 2 on the bottom. It's a fourth, right? Half of a fourth, half of the 4 on the bottom, 1/8, right? In other words, we're kind of doubling the denominator, etc. So next it would have been 1/16, just for reference. Number 4, multiplying by a third, starting from 81. So for number 4, we have 81, multiplying by a third of 81, 27. A third of 27, 1/9. A third of 9, 3. A third of 3, in other words, 2 divided by 3, right? 1. A third of 1, 1/3. 1/9, 1/27, etc. Just for reference, please do notice the initial value in each one of those sequences. So essentially, for the first sequence, we have a 1 as our initial value. For number 2, we have 1 as an initial value. Number 3, 16 is our initial value. And number 4, 81 is our initial value. This will eventually make it critical, but I'm just pointing it out for now, okay? So, geometric sequences. Geometric sequence. If the ratio of any term of a sequence to the preceding term is a constant r for every such pair of terms, then the sequence is a geometric sequence. The constant r is called the common ratio. So common ratio is what makes it a geometric sequence. So once again, if the ratio of any term of a sequence to the preceding term is a constant r for every such pair of terms, then the sequence is a geometric sequence. And once again, the constant r is called the common ratio. Let's find out if we have a common ratio for this example that we have in this case. Agreed? So let's see. Common ratio. Starting with the first one. If we look at the 1, we're technically going to use first the next value, the 2. So we're going to go 2 divided by the 1. So all is the next divided by the one we're looking at. So 2 divided by 1. Once again, next divided by the one we're looking at. Or the one we're looking at is the denominator. Agreed? The next one would be the one that's on top, the number that goes to the top. Numerator and denominator. So 2 divided by 1 gives us 2. Seems to have a common ratio of 2. Let's check at least one more example. I recommend checking several of the values. Alright, so let's take a look at the 2 now, and we're going to use the 4 since we're looking at the 2 right now. So in other words, 4 divided by 2. 4 divided by 2 gives us 2. Okay, there it is. And of course, going to the next one. In this case, we're going to look at the 4. Looking at the 4, that means we're going to use the 8 first. So 8 divided by 4, right, will give us 2 again. You're welcome to check by dividing as well. 8 divided by 4 should give you 2 on your calculator if you want to double check that. Okay, going for the next one. We have 8, so therefore we're going to use the 16. So 16 divided by 8 should also give us 2. Keep in mind, you can commercial multiplication, but be careful on how you do it, right? So we can try the 16, and in this case it's 32 divided by 16 gives us 2. And you can keep going on and so far as many times as you choose to, or until you realize that you're going to end up with a 2 if it's, in this case, a geometric sequence, which it is, right? Our common ratio is 2 for this particular case. Okay, since we saw our common ratio of 2, therefore we're gonna try the next one. For number 2, let's see, we're looking at the 1 and we're going to use the 3. 3 divided by 1 gives us 3. And let's try for the next one. Looking at the 3, 9 divided by 3, once again gives us 3. Going for the next one, etc. You can skip some examples or skip some of those in between divisions, right? Just check. In some cases you get to the point where you can check randomly sample, in other words, different values. So let's jump a little. Let's go for the 81. Looking at the 81, we're going to use 243 divided by 81, and we should still get a 3. And you can check further values towards the end just to double check, right? So going for the further values, there we go. Looking at the 729, we have 21 over 87, which if we divide it out, this is where a calculator could come in useful, right? Do remember to turn on your calculator. There we go. Turning on the calculator, 2187 divided by 729, right? Here we go. It gives us a 3. We should double check that. There it is. So in this case, our common ratio, once again, for this one now is 3. Let's go for the next example. Okay, on number 3, 16. Looking at the 16, we're going to use the 8. 8 divided by 16 will give us, hey, 1/2, right? Yep, double check the calculator if you need to. Okay, we can keep going or just randomly sample now, since we kind of got the idea of how it works, right? So randomly sample, let's go for the number 4, and we're going to use the 2. 2 divided by 4 should give us a 1/2. And now we can randomly sample further on ahead. Now let's say I sort of jumped significantly to the 1/2, therefore I'm going to use the 1/4 also. So 1/4 divided by 1/2. Oof, this might look terrible. How do I simplify something like this? A little tricky. Well, look over here to the left. Let's start with 1/4 divided by 1/2. And in this case, let's think about the fraction. It implies a division, right? 1/4 is on the top, so let me write as a regular fraction sign to make it easier to see. Okay, let's think about this like a tree. So we have 1/4 on the top side, which is the multiplication or the numerator of that particular tree as a reference. So let's watch how this tree sort of grows. And let's say all of a sudden a monkey shows up. And it's a monkey sitting on a tree branch. In other words, that 1/4 represents a monkey sitting on the tree branch. And we notice the 1, which is the head, is on the top. The bottom of the monkey sitting on the tree branch, which is the 4. So 1 is the head, the 4 is the bottom of the monkey. Just for reference, okay? To help you give you a visual. Let's say we extend this tree branch a little. And let's bring the 1/2 over. Once again, regular fraction sign to make it easier to visualize. And now let's say we bring in a monkey. Look at the monkey coming in from the right side. Swinging from tree to tree, right? Or in this case, line to line. And there it goes. It's on the tree branch there. So let's represent the 1/2 of this monkey that is not only suddenly joining our previous monkey sitting on the tree branch. Agreed? With the 1/4. So now we have the 1/2. And let's realize that the 2 represents the head of the monkey. The 1 represents the bottom or the bottom of the monkey. Agreed? What happens as the monkey swings up? Can you visualize that in your head? So if you can, then maybe you might be able to use this as a reference. As the monkey swings up, we get what we call the reciprocal, right? It flips, in other words. We flip the second fraction. In other words, the 1/4 was already there, so we left it as 1/4 times. And now the 1/2, the bottom, is the 1, stays at the bottom. The 2, which is the head, goes to the top, agreed? So it becomes 2 over 1. We flipped it. Or reciprocal of 1/2 is 2 over 1. And now we can multiply straight. 1 times 2 is 2, and 4 times 1 is 4. So there it is. 2 divided by 4, right? 1 times 2 is 2, 4 times 1, 4. And finally, simplifying. Half of 2 and half of 4. Half of 2 is 1. So we now have simplified it to 1/2. So let's bring it over finally to our simplified fraction, right? 1/4 divided by 1/2 became 1/2 overall. If the idea of the monkey simplification helps you out, go ahead and use it. If it doesn't, forget I ever mentioned it. So there it is. We found in this case that it gave us 1/2 again. And likewise, if we go to the next case scenario, 1/4, and you're going to use the 1/8 also, 1/8 divided by 1/4. Think about the previous monkey example, right? Let's bring it over real quick for reference. And so it makes it easier to visualize with the monkey example next to it. 1/8 times 4/1. That means we're going to take the reciprocal of, pardon me, I've already taken the reciprocal of 1/4, which became 4/1, right? So in this case, 1 times 4 and 8 times 1, since I had already taken the reciprocal of the 1/4 and it became 4/1. All right, so let's try it out. That means we're going to get 4 on top and 8 on the bottom. And then we can simplify this. Half of 4 becomes 2. Half of 8 becomes 4. Our final simplification should be 1/2, right? Let's take a look. There we go. Brought it back over on the right side. And finally, we can say that that is our common ratio. There it is. If you have a hard time visualizing this and sort of prefer to use your calculator for these types of examples, well, you're welcome to use the calculator as a reference as well. Let's go back to the previous example real quick. But you gotta have your right parentheses, or your parentheses in the right spot, I should say. Going back to the previous example where we had 1/4, so open up a parentheses, take 1 divided by 4, close your parentheses. And now we're gonna hit divided by, open up another parentheses, 1 divided by 2, close your parentheses, and hit enter. It gives you 0.5. You can go to math, hit enter for the option of fraction, option number 1, hit enter, and it converts that 0.5 to the fraction that you need, which is 1/2. That's a simplified version of it. If you want to try this again, you can hit second, then the enter button, and it repeats the previous statement, but you can try second, enter again, and repeat the previous statement again. And in this case, I'm going to rename the 1/4 to a 1/8. So I'm going to put an 8. And the 1/2 is going to be renamed to the 1/4. And that represents our last example there for simplification. Hit enter. And it gives you 0.5 again. Go to math, fraction, hit enter. And it simplifies it for you as a fraction as well to 1/2. There it is. Okay, proceeding on. Shifting a little. There we go. So going on to the next one. Common ratio for the 4. So our example number 4 is starting with the 81. And we have 27 is the next one. So we use 27 over 81. 27 divided by 81. Once again, recommend using a calculator. It should give you a third, right? If you have a hard time visualizing this, calculator definitely works. Clear out. 27 divided by 81, hit enter, go to math, fraction, hit enter again, and it gives you the simplified version, a third. Okay, proceeding on, going for the next one, 27. We're going to use 9. 9 over 27 gives us a third. And once again, continuing to the next one, we can randomly sample as well. Do keep that in mind, right? And going for the last two, we have 1/27 over 1/9, and it also gives us a third, so therefore our common ratio for this is also 1/3. There we go. So in this video we were basically learning about how to find the common ratio for when we have a geometric sequence.